Hello guys, so we're going to go ahead and get into our next part of classification, which is talking about some of the tools we use to show how things are more closely related or maybe not so closely related. And so we left off last time talking about systemics, which was looking at how we can group organisms based on these things that kind of look like family trees, but aren't exactly like the family trees we're used to seeing. So some of the tools, which is what we're focusing on today, that we're going to use in taxonomy, the first one we're going to use is cladistics. Okay, so the cladistics is a field of biology which uses evolutionary relationships to create what we call fan diagrams. Also, these are known as cladograms. And I'll show you a picture here in just a second. So a cladogram is a branching diagram that shows the relationships of organisms based on derived characteristics. Now the words derived characteristics, don't let those like freak you out. That just means based on what they have in similarity. Okay, so it bases it on like structural similarities, so it'll group things. For example, all the things that have fur will be grouped together. All the things that have 4 legs might be grouped together. All of the things that might have claws or talons might be grouped together. All the things that have wings grouped together. Okay, so it's just based on like how that organism is built. Okay. So a cladogram uses shared derived characteristics. Remember, that just means simple characteristics or similar characteristics to establish probable evolutionary relationships. So based on their body structure, we can kind of conclude which ones are going to be more closely related to who. So the birds, because of how they're built, are probably going to be more closely related between 2 species of birds compared to like a bird species and a lizard species. Okay, so we basically just look at their morphology or their structural characteristics to determine some of this stuff. Okay. Okay. All right. So how we read these cladograms, and I always like to introduce these to you because they're always a big emphasis, and sometimes they'll pop up on other. When we look at these cladograms, at first they look a little like discombobulated because you have lines going every which way, and there's characteristics, and there's like animals popping out the side. So the very first and most important rule when you look at the cladograms, okay, is that you're always going to use this diagonal line right here, okay, that has the characteristics on it. Now, the hint as to where to start, you're always going to start on the opposite side of where there's an animal. So notice there's an animal at the end of this main diagonal line here. So I can't start there, I have to start down here. Okay. So what happens is, almost like you were driving down this road, which was my analogy for the next slide, every characteristic you pass, that means every animal or organism after that characteristic will have that organism. Okay, so the lancelet doesn't have any characteristic before it. Okay, so we don't have a characteristic to describe it. However, vertebral column is next. That means that the lamprey, tuna, salamander, turtle, and leopard will all have vertebral columns, meaning they have spines. Okay. The next characteristic we would pass, going up this diagonal line, would be jaws. Okay, so the lancelet and the lamprey don't actually have jaws, but the tuna, salamander, turtle, and leopard do. 4 walking legs, okay, would be our next one. Salamander, turtle, leopard do, the other 3 do not. Okay. An amniotic egg, which means that it is an egg that has like amniotic fluid in it. So lancelets, lamprey, tuna, salamander do not have amniotic eggs, which is why they have to lay their eggs in like water or like a fluid-y type of atmosphere. And then turtles and leopards do. And the only thing that's going to have hair is our leopard. Everything else will not have hair. Okay. All right, so another way to think of this is you can kind of think of reading a cladogram like you were driving to a certain destination. Okay, so I always say, if this is your main road, okay, you're going to be driving your car on the main road, and then all these other little outlets are almost like people's houses. Okay, so let's say we're going to pick an organism to visit. Let's visit the tuna. Okay, so we're going to start at the very bottom, and we're going to drive to the tuna's house. So we're going to drive along, and we're going to pass vertebral column. Okay, and we're going to drive along and past Jaws. That means the tuna's going to have both of those, but before we get to 4 walking legs, we're going to turn and go visit the tuna. So because we didn't pass any other characteristics, it does not have those other 3 characteristics in this graph. Okay, if you guys get confused or start to have some questions as you come along with these, let me know. Okay, and I can maybe give you another explanation of them. Okay, so anything past that characteristic will have it. If it's not past a characteristic, like the lancelet, it won't have any of the characteristics mentioned on this graph. Okay, it won't have any of this stuff. And if it's at the very end, okay, and we keep driving and head straight into the leopard's house, it's going to have all of them. All right, so here's a little practice for you. Go ahead and answer the questions I'm going to embed into this video. And as you have questions, please let me know. Okay, and if you get stuck on anything, send me an email. Okay, I hope you guys are doing well. Almost the end of the week. Have a good one.